Salam sejahtera kami ucapkan kepada seharman dan rakan-rakan sekalian. Kami Kumpulan 1, ahli kami terdiri daripada Awang Muhammad Afiq, Muhammad Syamizi, Kili Berinemi dan Abang Lumang Hakim. Topik yang akan kami bentangkan pada hari ini ialah Welding Defects and its Prevention. Terdapat beberapa perkara yang akan kami bentangkan, iaitu Introduction, Welding Defects, Prevention dan Conclusion. Introduction. What is welding defects? Welding defects may be defined as a discontinuity or discontinuities that fail to meet the minimum acceptance per standard or specification. Defects may occur in excessive condition outside the acceptance limit, which risk to compromise the stability or the functionality of the welded structure. There are also acceptable discontinuities. The same type of discontinuity of a lesser degree might be considered harmless and acceptable. Types of welding defects: porosity, cracks, incomplete joint penetration, incomplete fusion, inclusion, and misalignment.
Diagram defects and its explanation. Firstly, porosity. Porosity occurs as a result of wheel metal contamination. The trap case creates a bubble filled wheel that becomes weak and can with time collapse. Next, we have cracks. The most serious type of welding defect is cracks, and it was not accepted almost by all industry. It can appear on the surface in wheel metal or the area affected by the intense heat. The last picture in this slide is incomplete fusion. This type of welding defect occurs when there is a lack of proper fusion between the base metal and the wheel metal. It can also appear between adjoining wheel pits. This creates a gap in the joint that it was not filled in the molten metal. The next one in this slide is inclusion. Only occurs when any welding technique uses flux shielding. Okay. Next, we have incomplete penetration. It occurs when the groove of the metal is not filled completely, meaning that the wheel metal doesn't fully extend through the joint thickness. Lastly, we have misalignment. It occurs because of carelessness and also due to joining different thickness, transition thickness. That's all.
Prevention. Porosity. Use low hydrogen welding process. Filler metals high in deoxidizers for excessive hydrogen to gas or nitrogen to atmosphere. Use preheat or increased heat input to combat high solidification rate. Clean joint surfaces and adjacent surfaces. For reducing excessive moisture, use recommended procedure for baking and storing electrodes. Cracks. Preheat the metal as required. Provide proper cooling of the weld area. Use proper joint design. Remove impurities. Use appropriate metal. Make sure to weld a sufficient sectional area. Use proper welding speed and amperage current. To prevent crater cracks, make sure that the crater is properly filled. Thank you.
Incomplete fusion. Therefore, first, minimum heat input to be maintained, correct electrode angle, avoid molten pool including the arc, proper cleaning of oxidized slag, and then inclusion, better interpass cleaning. Next, remove heavy convex blades. Do not use electrodes with damaged coating. Okay, we talk about incomplete joint penetration. Use proper joint geometry. Increase not root opening or use small electrode in root. Follow correct WPS, that's welding procedure specification. Misalignment. Work there are two. Workmanship, transition angle not to exceed 2.5 to 1. Okay, for the conclusion of welding. In conclusion, welding is one of various things that we may need in the field of mechanical engineering, and we have concluded on what is the welding defect and how to prevent it. That's all for me. Thank you.